طيب. Okay. In our previous class, we start talking about the vector space, and we knew it's a set of vectors define on that set, اللي هو فيه vectors, two operations. The first one, this one, اللي هي addition of vectors, okay, and this one, scalar multiplication. And for each one of these, there are 5 conditions should be satisfied. So for this one, 5 conditions, and as well for this one, there are 5 conditions. If all they are satisfied, then this set of vectors define on it these 2 operations. We call it what we call it a vector space, and we knew what are the operations. And we knew, for instance, that every Rn with the standard addition of vectors and the standard scalar multiplication, it is a vector space, R2, R3, R4, all of them, correct? And also we knew some other examples. طيب. شايفين الشاشة ولا لا؟ My screen is clear. Okay.
Yes, yes.
طيب. And we did some examples. We knew يعني this is a subset from R2. Okay, we defined on it the 2 standard operations, but we knew that this is not a vector space, for instance. Okay, why is that? مثلا the case when you multiply a minus a negative number times this, then the resultant like that does not belong to our space. يعني لو ده our space احنا we define the 2 operations, then if we took any element like that and we multiplied by a negative number, then the resultant will not belong to my space. It's out of my space, it's here. So the set is not going to be a vector space. This all, we did it in our previous class, and we took some different examples, correct? And we defined the subspace. What is the subspace? If we have any vector space, and we took subset from that space, and this set together with the 2 operations is a vector space as well. So we call this, بدل ما نسميه vector, yeah, it is a vector space. Yes, it is a vector space, but we call it, a subspace of the big vector space. Okay, so all the 10 conditions should be satisfied. Okay, طيب, to prove that this set is a subspace, it's not necessary to prove all the 10, because if it is a subset from this set, and we know the biggest set with these conditions, with these 2 operations, it is a vector space. So it is trivial that the others, يعني, that if it is commute, it is the elements on all this set is commute. Definitely, if you took it from here, are going to be commute. If it is associative, then as well here it is an etc. You will be left with only 3 things. What is it? You have to prove that the set, the vector, this one, it's not empty. At least it consists of one element, and that element اللي هو a 0 vector. Okay, that if you added any vector to this vector, then you're going to get the vector itself. So it's not empty, this set. At least it has one element, اللي هو the 0 element. And to prove that it is closed, that is, if you took any, under addition, if you took any 2 vectors from this set, okay, and you do the addition of vectors, this operation, then the resultant is here as well. It's not there. Okay, so it is closed under this operation. And as well, it should be closed under scalar multiplication, which is this operation. That is, if you took any vector from here and you multiply it by a constant, then the resultant should be as well where? Here, not here, not out. So if these three conditions are satisfied, then we have what? Then this is a subspace of the bigger vector space. Clear? And we did some examples in our previous class, correct? Regarding that type. Okay. Actually, we stopped last time with this example, and we proved that. And then this is a space. C is defined. C is equal to A plus B is a subspace of the vector space R3. Okay. We want to show actually that this is a subspace, and we proved it. We proved that it is not empty because it consists of these elements. Because this is, if this is 0 and this is 0, then certainly because C is A plus B is going to be 0. So the 0 vector is there. So that means this set is not empty. It has at least the 0 element. As well, for the second operation, if we took any two elements from here, we find that the resultant is an element here. For instance, I have to take the two elements from this set. How the elements in this set look like? They look like this. So I have to take two elements like that. So this is the first element, which is A, B, A plus B. Then the second element is A dash, B dash. This is how the elements look like of this subset. From where? From R3. The biggest is R3. R3 with these operations, isn't it a vector space? Yes. We knew that at the beginning and we took it like a theorem. Every Rn with the standard addition or scalar multiplication of scalar multiplication, it is, you know, a vector space. Okay. Type. So we took the two elements from here. These are they, and we did the standard addition. So this plus this, that, and etc. We got this vector. So we have to compare it with this. The first element, the second element. This element should be the addition of these two. Type. So this is the first element. This is the second element. The resultant should be the addition of these two. Isn't it here? Yeah, it is there. So that means it is closed under the addition operation, correct? So the resultant is here. And طبعا, this is for every element here. Why? Because I took these two elements arbitrary for any two elements from here. And I didn't take 1, 2, 3, for instance. Clear? You got the idea? You have, when you want to prove, you have to prove it for any two vectors, arbitrary, like that. Clear? Type. And also, we proved that if we multiplied any vector from here by any constant, the resultant as well will be where? Will be here. Okay, so this is the vector I multiplied by a constant. We called it R here, which is a real number, scalar. So the resultant is RA or RB or R multiplied times A plus B. But what is R multiplied times this? This is RA plus RB. So it is like that. Does this one belong to my set or no? How can I know it belongs to my set or no? Does it look like the elements here? How they look like? The first, the second, and this is the addition of the first with second. Type here we come. First, second, and this is the addition of the first with second or no? Yes. So that means it belongs to my what? To my subspace. Clear? Okay. The example is clear. Type. Now we do another example. Type. Now, type. Show that W is not a subspace. Type. For subspace, there are three conditions. I have to test them. Type. So, what is the first one? The first condition, it is not empty. Is it empty or no? Does it? أول حاجة, we should have the element 0, 0, 0 for the standard addition of vectors. طيب, هل this element is here? or no? Type, what if I put the A is 0 and the B is 0? So this is going to be equal to 0 plus 0 plus 1. So I can never find this element. Immediately I will say what? It is not a vector. It is not a subspace. It is not a subspace. Why? Because this vector is not there. Clear? I can prove it like that or else. And احنا قلنا we have three conditions. طيب ده معناه شنو? The first condition is not satisfied. By the way, sometimes ممكن يكونوا two satisfied and the third is not مثلا. Okay? So you have to شنو? To just look after these three conditions. If any one of them fail, so that means it is not a subspace. Clear? طيب. So one student can prove it like that. Another student can think about what? The addition of two vectors. طيب. احنا قلنا شنو? If it is a subspace, then it should be closed under addition of two vectors. That means if I took from this subspace here, okay, of this big vector space, this is my vector space V, and this is my W. If I took any two vectors and I add them, the resultant should be from W, correct? Type. Let's take two elements. They should look like this. So we can assume that the first one, A or B, A, B plus 1. So this is my first vector. I pick it from this set. Now another vector, then this one, another vector. Type. Now, what if we add them? Is the resultant is also here or no? When you add them, you're going to get A plus A dash, B plus B dash, A plus B plus A dash plus B dash plus 1 plus 1. Type 1 plus 1, it is 2. Type, هل is it the resultant is an element here or no? Is it an element here or no? Tell me, is it an element here? هل هو عنصر من هنا ولا لا؟ انتوا معاي؟ Do you hear? Okay, so it is an element there or no? Yes, it is an element there. هل this one look like this one? How they should look like? How they should look like? The first, the second, and this should be first plus second plus 1. Type, okay, this is the first, this is the second. This is the first, this is the second. It should be plus 1, not plus 2. So that means when I took two elements, the resultant vector, and I make the addition operation, the resultant one is not here. Where we find it? We find it out here, because this is not plus 1, this is plus 2. Isn't, you know, what does that mean? This means that this is not a subspace. It is not the subspace. Why? Because this element does not belong to here. Type. So here I found that it is not a subspace using this is the second. احنا ما عندنا 2 3 صح? So this is the second. Okay, اللي هو addition. The addition of two vectors. طيب, also we can prove that it is not a subspace of how? If we took one vector. Okay? If we took one vector, just like this one, and now multiplied by C. So what is the resultant? The resultant is going to be equal to CA, CB, and when I multiply here C, it's going to be CA plus CB plus C, like that. Type, هل is the resultant as well an element in this space or no? That means, does it look like the elements here? Does it look like this one? First, second, addition of the first to second plus 1. No, it is not. So CA, CB, So this is CA plus C, but this is plus C, not plus 1. يبقى again using we prove that it is not a subspace using what this is the third condition that it should be satisfied. Any proof of these three is correct. You have to prove just using one of them. Clear? Type clear. Any question for now? Type now here there is another example. Let x equal to 1 plus 2 plus 3, 4, 5, 6. So this is the first vector and this is the second vector. Shows that W, okay, a space W, يعني احنا we have this was our original vector space. Now I took from this vector space two elements, this one and that one, okay, اللي هم الX والY. And now what? I took a space, our subset from V. How the element of this space look like? They are what? The linear combination of X and Y. That means we are multiplying X by a real number, let's say A, and Y times another real number, let's say B, and then we add the resultant. And for every real numbers A and B, this combination of the vectors where they should be in this W. So that means this is W. And it has certain vectors. It is this set is a subset from this. How the elements here look like? They are all a linear combination of only these two vectors. That means the vectors here, they look like A في vector, the first one, which is X, plus B في Y, where what? Where A و B are real numbers. Clear? يعني for instance, if I took the vector 2 multiplied by X ومثلا minus 3 and multiplied في Y, and then find the resultant vector. This vector where? It is here in W. Clear? If I took second time I changed, this is بدل 2, this is 3. مثلا I took this is 0 and this is 5. Again, they are numbers. The resultant where? It is here. Next time I took this is half بدل 2 and this is مثلا 5 over 3. Okay, so where is the resultant as well? It is here. So I generate the vectors there, okay, by linear combination only of these two vectors. Clear how W looks like? Okay. Now he's asking me to prove that as well. This is a subspace. The new space, this one, which is subset from this, okay, it is a subspace. طيب, again, احنا قلنا to prove انه subspace we have to prove three things. The first one, it is not empty and it contains the vector what. نحن وين في R3 لازم element they look like يكون فيها 3 component, correct? طيب, هل element 0 0 0 belong to W or no? We have to see that. Does it or no? Yes, it should be there. Why? How can I get it? احنا قلنا how the elements there look like. They are the vector X, which is this one, okay, times a constant, plus the vector B multiplied vector Y, correct, multiplied by a constant, another number. طيب, what I want 0 0 0. طيب, if I multiply the first vector by 0 and the second vector by 0, I'm going to get the 0 vector, صح؟ يعني مثلا اللي هو 0 الفيكتور الأول هو شنو؟ 1 2 3, correct? Plus 0 times what is the second vector? it is 4, 5, 6. Correct? And when you multiply 0 here, you're going to get the vector 0, 0, 0. Correct? Plus, I don't know what's happening. Type plus, again, plus what? Plus 0, 0, 0. Yes? So what is that? I'm going to get the vector 0, 0, 0. 0x plus 0y is going to give me the 0 vector. Okay? For simplification, I'm not writing. I know what is x. X actually it is this vector. So no need to write it, because you know that 0 times any vector is 0. If you want to write it like I did here, do it. Okay? But here for simplification, it's okay, it's fine. So the resultant is the 0 vector. يبقى, yeah, the 0 vector belong to W. Yeah, this is true. يبقى we finished from the first part. Now the second part. What is the second part? It should be closed under addition. صح؟ اللي هو addition of two vectors. اللي هو standard operation of addition. طيب, is it or no? I will take what? Take two elements from here. Any two vector. Let's say this one. Okay. مثلا. And this one. طيب, هل the resultant as well it is here or no? This is our question. Okay. How, when I take an element from a space, it should look like the elements in that space. So what is the first vector? Here you say that let what? A1 x plus B1 y. Okay, this is be the first vector. And هاخد الثاني شنو؟ A2x plus B2y. This is the second vector. Now what? We want their addition. So now what we do? We add this one to this one. طيب. This is the first vector. This is the second vector. How can I add? It's easy. Okay, because where I want to reach to the answer like that. Correct? Type. So what I do, I'll put the x with the x's, والy's والy with the y. طيب يبقى هيكون عندنا شنو؟ إذن A1 x plus A2 x plus B1 y plus B2 y. This is the resultant vector. And this one I can write it as this is equal to, take x as a common factor. So it is A1 plus A2 x multiplied by x plus, also take y common factor, B1 plus B2 y. Correct? Type, does it look like this or no? Yeah, it looks like that. Because when you add two real numbers, the resultant is a real number. And you can write it as this is equal to some certain number. Let's call it C. So C phi x, okay, plus مثلا D phi y. A number phi x plus a number phi y. يبقى yes, the resultant element, it looks like the elements of that space. That means it is as well, it is an element there. يبقى the second condition is met or satisfied, correct? اللي هو addition of any two vectors from this space as well, it is where it is there. Okay? طيب, what remains? جماعة, أنا instead of writing the vectors themselves, I'm writing x, y. Is it clear? But you can write A for this one and put it, and plus here, okay, B1 في this vector, but don't take certain values. يعني ما تاخد 2 وhalf numbers like that. Why? Because we have, when we're proving, we have to prove for general case. that it's always satisfied. No even one case خلاص that will make it that will not be satisfied. You got the idea? So you have to write A or B or C1 or C2 or whatever, but not numbers. The numbers only for this, because these are the two vectors I'm taking to span this space or to generate this space. Clear? وبدل ما اكتبهم نفسهم, just I'm writing what I'm writing x, y. I know what is the x. X refer to this vector and the y refer to that vector. Clear for all? Clear? Clear? Okay. Remains the last. What is the last condition? The third one. The third one اللي هو scalar multiplication. That is, if you took any vector from your space, this space, okay, is C times this vector as well, it is here in this space or no? طيب, for instance, I will take the vector A, okay, from that space A1 or A, x plus by. And then I multiply times any number, real number. You can call it R, you can call it C, you can call whatever. If I called it C, type, هل the resultant as well it is here or no? Okay, so this one is equal to C phi A phi X, because this is a number and this is a number. X هو vector plus what C phi B phi Y. Okay, like that. Type okay. But a number time a number, it will give me a real number, correct? So this is actually a real number and this is a real number. If you want to write it, مثلا you can call it what, nx plus m plus mx y, where n and m are real number. Is it here or no? Yeah, it is there. يبقى yes, the three conditions are met. يبقى it is what? It is a what? It is a subspace. Clear? يبقى yes, the space that is generated by these two vectors by doing a linear combination, okay, it is a subspace for this vector space. Clear? And now this one, we will take it as a theorem. Type, what is this theorem? Theorem state like that. If you have any vector space, okay, this is your vector space, V. Take a group, يعني انت you have many vectors here, correct? This is a vector, this is a vector, this is a وهكذا, correct? Take some of these vectors. Take some of these vectors, okay? And then with these vectors, generate a space by doing linear combination of these vectors. So you will get, for instance, let's say this space, call it W. How the elements of this space look like? They are a linear combination of these elements. So using these elements, I'm getting the vectors here and even, okay, there. Type يبقى this space of W, how it looks like elements حقته. They are elements شنو هو set of elements مثلا C1 في الفيكتور X1 يعني لو كان ده X1 مثلا and this is X2 this is X3 X4 وهكذا CX1 plus C2 X2 plus C3 X3 okay plus وهكذا لحد آخر vector, let's call it K. So CK في XK. So this vector is the set, this, okay, of vectors like that, such that طبعا شنو C1 و C2 لحد CK are معلوم belong to R. They are real numbers. The same like what? هنا كان only two vectors, correct? And the space كان هو عبارة عن الset this element حقته such that A Now, instead of only 2, any number of vectors. I took them where? From this big vector space. And now I generate a space from these vectors. So, يبقى I have this one. اللي هو the set W of vectors. Now, the theorem states that this new space, it is a subspace of that vector space. If you find anything like that, you have some elements, and from them you generate a space, okay, by doing linear combination. Then this space is a subspace from that vector space. Clear? And we give it a name. This one, yes. And then this space, since this space we generated only by these vectors, we will call it span these elements. But what are these elements? They are x1, x2, x3, like the xk. So we call it span these elements. We will call them s. These elements, we call them s. These elements here, we call them s. And we use the elements in S to generate my space. So this one, since we generated from this element S, so we say that W is equal to span this set اللي هو S. What are the elements في S? elements تاعين S هم شنو؟ هم X1 X2 X2 وهكذا لحد XK. Clear? يبقى what we say we call it span S. يبقى span S is what لما نقول W هو span S, that means it is the space that is generated by the vectors in S اللي هم هنا by doing linear combinations. كيف هجيب الست؟ كل مرة هاخد how can I generate the set? Every time just you put some real numbers there. 1, 3, 5, 19, half, whatever. And then get a vector. Then it is there. Next time, another numbers. Then you get another vector, and etc. You got it? Got it? Type. And the statement of the theorem, this set, always it is a subspace from your vector space. Clear? يبقى always span S is a subspace of Rn. طبعا here we are talking about the real Rn, okay? A space, Rn, not any vector space, this vector space. And we're defining on it a standard operation of addition و scalar multiplication, okay? طيب, here there is an example. Shows that W, okay, this elements of W, our vectors, they look like that, such that A and B are real number. Prove that it is a subspace of the vector space R3. Now before, to prove it is a vector space, we said that we're going to prove 3 conditions. واحد, it is not empty, correct? And easily I can prove that it is not empty. It consists of the vector 0, 0, 0, correct? It is belong to your set. Why? If you took A0 will be 0. So what you will get? 0 plus 0, 0 by 0. صح? 0, 0. So easily. Second one, take 2 vectors. So I'll take this one. Okay. And the other one, I call it A dash plus B dash. A dash minus 2B dash وهكذا. So another. And then I do the addition. يعني we prove the second that it is closed under addition, correct? اللي هو second case. You have to prove that what? Closed under addition operation, correct? That if we took any 2 vectors, then the resultant as well, it is where? In the set W. The third, we have to prove that closed under operation of scalar multiplication, when you multiply by scalar. Okay, but there is how we do. You multiply this by C. So what you're going to get, in the CA plus CB. So a number, a number, correct? Here, how they should look, same like that. So now this is CA, this is CA, this is CB. So here twice this number. So minus, yeah. So it's going to be, this is CB, هنا هيكون في CB, correct? And etc. So it's clear. It's going to be closed under scalar multiplication as well. But there is an easier way now to prove that this is a subspace. How? Using this last theorem. If we could find 2 vectors, 3 vectors, 4, 5, 7, no matter how many, okay? So set of vectors like this, and we generate our space using these vectors by doing linear combination, I'm done. Type, do we have these vectors? Let's go back. Now, what is this vector? What is the vector a plus b, a minus 2b, 2a plus 3b? What is this vector? Type. We can write it like that, correct? Here we have a, a. So I can write it like what? A, و2a, correct? Plus another vector. What is the other vector? اللي هو فيه البيز. لو كان في one element ما فيه b كان هحله 0, correct? كان I'll put in its place 0. طيب, then plus what? b, correct? Minus 2b, then plus 3b, correct? Like that. Now what? Take the a as a common factor. So what you will get when you take a? You will get this. Type, take the b from this one as a common factor. What you will get? طلع البي برا هتجي 1 minus 2 and 3. 1 minus 2, which is this vector, correct? What is this now? What is this now? Isn't it a linear combination of these 2 vectors? Isn't it? Yeah, it is a linear combination of these vectors. So that means my space W is generated from these 2 vectors by doing linear combination for them, correct? So that means it is equal to شنو? It is spanned. W هو عبارة عن span طوالي معناها linear combination of some vectors. Which vectors? These vectors. اللي هو الست ده هنسميه شنو؟ S. يعني معناها W is equal to span S. Where what is S? S is the set of vectors. What? 1, 1, 2. While other vector is the vector 1 minus 2 to 3. So I proved that my space, this one, space حقيقة, okay, that is my space, okay, is generated from these some vectors by doing linear combination. Actually, we have here, there are 2. It's generated by these 2 vectors. So it is what? It is a subspace from the big vector space. Okay? يبقى it is شنو? It is since أنه W بيساوي span S and this is your S, so it is a subspace. يبقى W is a subspace. مش easier من this one, correct? For some examples you can do, and it's easy. Clear? And this is in particular 200 في الحالة بتاعت نتكلم عن RN, R1, R2, R3, and this is هنا in our course we're dealing in this chapter with RN. الاليمنتس في RN. طيب
دكتورة من بعد إذنك دكتورة، أنا دخلت قبل شوي داخل متأخر ما قريت الإيميل.
ما في مشكلة. أوكي.
طيب شكرا.
عفوا. طيب. Let W is equal to this one. Okay. Where ما دي B, A, B belong to R. This is B, okay. B a subset of the vector space R3. يعني عندي الفيكتور space we know with the standard. أول ما أتكلم لك على الأوبريشن معناها the standard ones. Okay, we have this is our space اللي هو R3 with the operations اللي هم الاديشن والscalar multiplication. Correct? Okay, we took a space here which is subset from our big space. How the elements of it look like? They look like this. Then he asked me to prove that what shows that W it's a subspace. Show that it is a subspace. We can go and use the three conditions there and prove. But it's clear in this case, it's easily I can use the last theorem. If I can find some elements here, okay, and these elements who the set S and this set generate all the other elements in W by doing a linear combination, I'm done. يبقى immediately W is equal to what? W is what? It is a subspace from R3 مع الاديشن والscalar multiplication. طيب, now let's try to find هل I can find some element that when I do a linear combination of them I find or generate the whole W. Let's see. طيب, this vector I can write it. It is equal to what? Now it's في A وفي B. طيب, so it is A, correct? 2A and then 3A. Okay, and then plus what? Plus what about the B's? Minus B. Here there is no B. يبقى معناه شنو 0. وهير 4B. Okay, now take the A and B out. So, but the addition of these two vectors is equal to what? A times the vector, what? 1, 2, 3, plus B times the vectors -1 and 0 and 4. Correct? That means it is in the form A في certain x, so this is my x, A is a real, plus B ممكن أسميها x1 x2 لو عايز أو xy ما في مشكلة. The naming. You can call it anything.
سامية.
نعم. Yes.
قاعدة تفصل الشاشة وترجع.
Yes, I don't know what's the problem, but just for part of a second, صح؟
أيوة كذا كذا كأنها
Okay, yes, but let's finish this part وبعدين I'll check where's the problem, okay?
Okay.
But it's clear. Is it clear for all?
إيه واضحة بس لأنها تفصل بعض المرات.
Okay. يعني بتطلعك برا كله وبعدين ترجع؟
إيه كذا كأنها تأشر يعني تفصل الشاشة تصير سوداء وترجع.
I don't know what's the problem. I'll check later, okay? عشان not to waste the time. طيب.
ممكن إنك تسوي share again ويضبط.
Okay. A x1. This is in the form A x1 plus B x2, correct? So it's clear. I generate this space using these two vectors by doing a linear combination. يبقى it is a subspace. صح؟ يبقى W, what we say that W, my space, is spanned or generated by a certain set of elements who span S, such that what is your S? What is the set that generated W? It is this set اللي هو 1, 2, 3. You can write them اللي هو الفيكتور الأولاني do like that and put the first vector اللي هو 1, 2, 3, correct? And the second vector which is -1 and 0 and 4, correct? So W, this set is equal to span S. So I'm getting this is the S and this is the span S. So it is a subspace of that one and I'm done. Clear? Now, is this vector belong to W? Explain. هل this vector belong to your W or no? How can I find? It will belong to W if it looks like these elements there. It belongs to W if it looks like these elements. That means what? That means we should have this vector is equal to this for some A and B. Okay? طيب. Okay, so what? احنا طبعا this خلصناه اللي هو W بتساوي span S اللي هو span this vectors, two vectors يبقى it is a subspace. Then in the second part he told me he asked me to find a subset S of R3 that spans W, that generate W, that I can get from it W. What is this subset? اللي هو السبسيت ده منه this and this. So what is the subset? It is the set this one and this one. Okay, clear? Type the last thing I want to check is this one. It is here or no? If it is here, it should look like that. That means what? That means I want to find the A and the B that they will give me this vector. If it is here in this space W, then I should find A or B. Okay. When I put them here, I'm going to get 3. When I put it here, I'm going to get 2, and I put it here. So how we do that? Okay, what we do? We equate this vector by this vector. This is equal to that. Then that means 3 should equal A minus B. 2 should equal to 2A. Minus 5 should equal to this. What do we have? We have what? System of linear equations, correct? يعني حيكون this one حيكون عندنا what? 3 is equal to A minus B, and then 2 is equal to 2A, and then minus 5 is equal to what? 3A plus 4B. Isn't it a system of linear equations? Yes. Then we want to solve for A and B. We want to find the values of A and B. Yes. How we do that? Put it in the augmented matrix, reduce to the echelon form or the upper triangular form, and then find A or B. So you will end up, okay, from the equating, this is the augmented matrix, and then you go and solve, and this is the system. Okay, طيب هل في solution or no? Yes, there is a solution. What is that? A من هنا 1 في A is equal to 1. That is the A is equal to 1. What about the B? 0 في A plus 1 في B اللي هو B is equal to minus 2. So the B is equal to minus 2. If you want to make sure that your solution is correct, take this A, substitute it here, and this B and substitute it there, and check are you going to get فعلا الفيكتور حقك اللي هو احنا عايزينه اللي هو 3 و 2 و minus 5. Okay, let's try. Take ال A 1 وال B قلنا كم؟ minus 2. So 1 minus minus 2, that is 1 plus 2 is equal to what? 3. Isn't it 3? Now 2 كال A اللي هي 1. 2 في 1 اللي هي 2. Now 3 في 1 plus 4 في minus 2. 4 في minus 2 minus 8. Minus 8 plus 3 هي minus 5. يبقى yes, correct. You got it? يبقى if I got the values بتاعت ال A وال B, I'm done. Yes. That means your vector, it is there in the space here. Okay, but if there was no solution لو ما كان في حل, then that means this vector is not there. لو كان ما جاني حل. But here in our examples we got there is a values A, there is a solution. So there is a value for A and value for B. Okay, and then that means your vector, yeah, it is there in the subspace W. واضح ولا في سؤال؟ واضح? Is it clear? Any question for now? Okay, I just will continue for more 10 minutes before I start the other class, please. عشان we can easily finish this chapter. طيب now when you subspace and we knew what is the vector space and we knew a subspace a subset from the vector space that its elements are a linear combination of certain elements, it is a subspace. Now, for the vector space, okay, or the subspace, if you could find some elements, okay, مثلا خلينا في subspace, you could find some elements that generate this such that your W is equal to span this set, span S, okay? And the elements here of S معلوم اللي هم الset S هم فيه شنو؟ set S is set of elements of vectors x1 x2 وهكذا صح؟ sorry لحد xk. Okay, so this set of vectors x1 x2 لحد xk ماله المفروض يكون الاليمنتس حقته مالهم linearly, if they are linearly independent, and we knew what do we mean by linearly independent in our previous class, correct? So if this happened, then we say that they are the basis of this subspace. They are basis for this subspace. Ibga, what are the bases for the subspace? They are the element that they generate this space. And they are linearly independent. That means I cannot get rid of one of them to find this W. All that they are important to generate W, because no one of them can be given in terms of the others. If one of them can be given in terms of the others, that means there is no need for it, because they will act, you know, without this element. They can replace it. خلاص, no need. It is extra. So I don't need it if it is extra. Okay, يبقى what are the bases? The bases هم a set of elements S such that these elements S span the space. Okay, البيزز بتاعين W هم شنو؟ What are the bases of W? They are the elements في set S such that by doing linear combination of them we get W, or another way we can say that span S is equal to W. Clear? And moreover, these elements, I need all of them. They are very important. Okay, I cannot cancel one of them. That means, you know, no one of them can no two can replace any one of them. Okay, that means, you know, that means they are linearly independent. So if this happens, then we say that there are the basis for the set for the subspace W. They are basis for subspace W. Is it clear? Is it clear? Clear for all? What are the bases? واضح يعني شنو basis؟ واضح؟ طيب. I used to give an example عشان you don't forget. طيب. If you have any table, okay, to let it stand, you need, you know, you need some legs عشان تخلي table standing, correct? Yes, like that. So think of them as if they are the basis for this table, to let this table stand. So as if this is your set S, you're looking for. If you removed any one of these, then the table will fall. Correct? So all of them is important. No one of them can act, you know, يعني هل this three can act, okay, in the place of this, and can I remove this? No. Clear? يعني أنا this just for comparison, as if, okay, to make things يعني what can I say, يعني to some extent clear. Okay, you can remember it with this. Okay. طيب يبقى all they are important. يبقى this is the شنو the basis for the table. Okay, so you got to some extent. Okay, what's the idea here? You cannot forget it now. Yes. طيب هل only this four legs in this place, or I can find others? I can find others. Instead of that, I can put the legs, for instance, here. Okay, مثلا here and here and here, and also the table will stand. That means for the same subspace, you can find. Yes, it is blinking even for me, and I don't know what's the case, but let's finish this part. When I'm not using the pen, it's okay, correct? Okay. Right. Now, this again, there are new bases for the same system, correct? So the same system can have different bases. You got it? يبقى any of them that they can generate the space, any of them that will generate the space by doing linear combination, خلاص, and they are linearly independent, we call them bases. We call them, you know, bases. Clear? Okay. طيب. So a vector, a set of vectors, this in the vector space Rn, and by the way, not only for subspace. Now, even if we want to talk about this, the big vector space. So for this big vector space also, if you could find vectors that by doing linear combination of them give you the whole vector space Rn, R1, R2, R3, R4, whatever, okay? And these vectors are linearly independent, so you say that they span the vector space. يعني ممكن تلقى vector span. طيب احنا لما نتكلم عن البيزس نتكلم عن bases سواء for the big one or the small one. طيب the bases for the big one, what are they? Also the same definition. You have to find some elements in from this big subspace. These elements معلوم they should span this space. بدل W هنا we put V. They should give you the whole V. They should give you the whole V. Clear? So V is equal to span S. Okay? Every element here is, you get it by doing a linear combination of this. So you got this one. Okay? And these vectors, they are linearly independent. يبقى you will say that they are what? They are bases for this vector space. Clear هاتون؟ هاتون clear؟ احنا هنا بنتكلم عن Rn R1 R2 R3 R4 بنتكلم عن السبيس. Okay, such that يعني كل الفيكتورز elements are inside them are شنو real numbers. Okay. Now.
السلام عليكم.
وعليكم السلام.
أقول لك يا دكتور بس أنا عندي محاضرة بالإنجليزي، تسمحي لي أخرج؟
Okay. إذا حضرت الكلاس تاع المراجعة اللي حيبدأ بعد دقيقة it's okay you go.
طيب شكرا دكتور.
A set of n vectors S is equal to x1 in the vector space Rn is a basis for Rn if S is linearly independent. Now he make even life more easy. He said, now, if you're dealing with vector space, okay, that is Rn under addition and scalar multiplication, oops, don't know what's wrong, and scalar multiplication, okay, like that, then if I gave you any vectors, مثلا احنا في R3, I gave you 3 vectors, and these 3 vectors are malum linearly independent, then immediately these 3 vectors are what are bases for R3. Completely and 100% they will span that space. You can find any element في R3 in terms of them. ده الستيتمنت بتاع الثيورم here. You got the idea? طيب تاني. Let's say لو كان عندي R4 with these 2 operation اللي هو addition of vectors, standard addition وال standard scalar multiplication. So in R4, if you could find in R4, if you picked any 4 vectors, احنا R4, so 4 vectors. You picked any 4 vectors from R4 and you find that these 4 vectors are linearly independent, ولقيتهم linearly independent, immediately that they are bases. ده الستيتمنت. Okay? يبقى they will generate R4. Any vector في R4 you can find it in terms of these 4 vectors by doing a linear combination. يبقى سهل علي في حالة I'm talking about R3, R4, R5, R6, R7, whatever. That is the only condition I have to test. No need to test this. Just you have to test that linearly independent ولا لا. This is if we are talking about Rn only. You got it? For the big vector space, not a subspace of it. Let's read that. A set of n vectors. Okay, اللي هو S, a set S فيه x1, x2 لحد xn. المراجعة just after, let's say, 10 minutes. طيب, a set of n vectors x1, x2 لحد xn in the vector space Rn is a basis for Rn if S is linearly independent. خلاص بس ده شرط واحد. If it's linearly independent then we are done. طيب okay, let's see here. W is this set. We had it before here. Same element set here. طيب. Be a subset of the vector space R3. Find the basis for this W. Okay, now W is part. It's here. We generate it from this. It's a part, not all Rn. He need the basis. That means we have to search for the set that will generate this space. This one. So we are looking for what? For span S. Type. But already in the previous example, we found that span S. What is S? It is this one. These 2 vectors. So already I have the set of vectors. Now what remains? To test that these vectors are linearly independent ولا لا. If they are linearly independent, we are done. These are going to be the basis. يبقى فضل لي اثبتهم a new thing. Are they independent ولا لا? طيب how we prove independent ولا لا? Do you remember how we prove that they are dependent ولا independent? What we do? We need C1 في x1 plus C2 في x2 is equal to 0 and find the value of C1 and C2. Correct? اللي هو احنا قلنا عشان ما يكون dependent ولا independent what we do we find C1 x1 plus C2 x2 and we assume that this is equal to 0. Okay, and then we find if this is equal to 0 and we find that the only way out this should equal to 0, all of these are zeros, then that means it is linearly independent. لو جات غياب معناها dependent. يبقى what we do now, we do this, we do and we solve like we did before. هتعمل this C في C1 and the C2 وقلنا هنلقى system of linear equations and we put, and this is going to be the part of the A, and part of the B هيكون شنو 0 0 and then you solve. Correct? Reduce to the echelon form and find the value of C1 and C2. If you find C1 C2 are equal to 0 خلاص you're done. يبقى it is linearly independent. طيب or else what? But determinant. طيب هنا but I can't find determinant for this. No. هل هنا ممكن استخدم determinant? No. صح؟ ليه؟ لأنه I have 3 rows. احنا determinant we find it only for square matrices. طيب هل دي square matrix? No. It's not a square matrix because I have 2 rows. Sorry 3 rows but 2 columns. يعني لازم يكون كان في column ثالث عشان اثبت dependent ولا independent. Clear? طيب يبقى شنو؟ Here we had انه this set is spanned by this في example. Correct? فضل اثبت شنو؟ They are linearly independent ولا لا؟ لقيتهم linearly independent خلاص I'm done. يبقى they are the basis. يبقى this space البيزس حقته they are these two vectors. Clear? Now أنا وين في R3 اللي هو RN متذكرين؟ a big one. طيب this is اللي هو شنو؟ R3. طيب and I took these 3 vectors. Are they basis for this R3? Can I find any vector here in terms of them by doing linear combination or no? What the theorem state? It is enough to check that they are linearly independent ولا لا. It's enough. وطب هم هيكون عندي لو خطيتهم في صورة بتاعت matrix 3 rows 3 columns. So to check that they are linearly independent just find the determinant. طيب الdeterminant equal to شنو؟ equal to 6. معناها determinant ما ساوت صفر. يبقى they are linearly independent. يبقى they are basis for R3. That means any vector في R3 عايز تجيبه you can find it in terms of this. صح ولا لا؟ And in particular and we're coming for that just for a while. In particular الفيكتور لو كان عندي 1 0 0 و 0 1 0 و 0 0 1 are they basis for R3 or no? هل أي vector في R3 I can find it in terms of this? Yes. It's clear. لو هنا عايزة مثلا الفيكتور 2 5 minus 7 you multiply this by 2 and this one by 5 and this is minus 7 and add them up you're going to get this vector. Correct? So these are another basis. اللي بيهمني أنا في R3 عايزة 3 vectors 1 2 3 ويكونوا linearly independent. طيب هل these linearly independent what we do? Can I use the determinant here to prove that it is dependent ولا independent? Yes. لأنه لما تيجي تخطهم الثلاثة وتجيب determinant. Okay. So we remove this. Okay. So it is what? It is a diagonal matrix, correct? Sorry. So it is a diagonal matrix, correct? يبقى what? Just we multiply diagonal اللي هي معناها determinant is equal to 1. يبقى determinant is not 0. يبقى they are linearly independent. يبقى these are bases. يبقى R3 can have different bases but they should be 3. 1 2 3 وبعد ده to test انهم dependent ولا independent. نفس الحكايه this 3 dependent ولا independent. جبت determinant لقيتها ب 6. They are linearly independent. يبقى yes they are bases. Any vector here حتى 2 5 minus 7 you can find it in terms of this. If I want to find it how can I find it? We had it before. كيف اقدر اجيبه؟ How can I find it? We need a number C1 في this one plus C2 في this one plus C3 في this one is equal to what? Is equal to this one. Go and do it as homework. So what we do? We put it, هنلقى انه عندي linear equation or system of linear equation. So we find an augmented matrix A and here the B, and then we solve. Clear? Okay. You can find a C1 or C2 or C3 as we did before in a previous class. Just 1 minute. After I'll start the new class. طيب E1 الفيكتورز احنا وين في R2. I have two vectors. Are they bases ولا no? Yeah, they are bases. Why? Because they are linearly independent. No one of them I can get it from the others. صح? That is, if I found the determinant of them, the determinant is 1, is not equal to 0. If they are linearly independent, if yes, they are bases for R2. That means every vector I can find it in terms of them. في R2. واضح؟ يبقى for every vector x equal AB belong to R2, x بتساوي A في this vector plus B في this vector, correct? عايزة 2 5 هتمطلب ضف 2 ضف 5. So always في R2 1 0 0 1 is a basis. في R3 1 0 0 0 1 0 0 0 1 like this one is a basis. في R4 لازم يكون في شنو 1 0 0 0 بعدين 0 1 0 0 بعدين 0 0 1 0 بعدين 0 0 0 1 correct 4. Then immediately it's clear they are bases. في others, yes. Like here in this example, we found that also they are bases for R3. Okay? طيب. And this already we did it. This are bases for R3, correct? Now, what is the dimension of the vector space? You have how many bases for R3? 1, 2, 3. So we say the dimension of R3 is equal to 3. يبقى what is the dimension? How many bases they can generate the space? So for R3, R4, R5, R6, it's completely clear from the first look. R5 has a 5, R6, 6, R19, 19, وهكذا. Clear? لأنه we knew that for Rn أخذنا theorem, correct? For Rn we need what? For Rn we need n. N vectors يكونوا linearly independent. Okay? يبقى الدايمنشن حق السبيس هو شنو؟ The number of vectors in a basis. البيزس فيه كم vector that is going to generate my space. فيه 3 يبقى the dimension of this is 3. فيه 7 يبقى the dimension is 7 وهكذا. And as a by definition a zero vector اللي هو الفيكتور 0 0 0 بس this one has dimension 0. نقول عنده dimension كم؟ 0. 0 vector. يعني السبيس حقي بس فيه 0 vector. كم الدايمنشن حق this vector it is 0. ويقول الدايمنشن is 0. R2 هيكون 2 R3 3. Okay, the last PowerPoint. Now after it we'll start our class. Okay, let S be this set of vectors x1 x2 x3 x4. We need the basis for the subset W اللي هو equal to شنو is spanned by this one of R3. And what is a dimension of W? طيب quickly احنا شنو عندنا we're talking about what? R3. This is your what? Your R3. This is my R3. طيب what is your W? You have set of elements في W. They are 4. And using this 4, we generate a space spanned by S. This is W. W is spanned by these 4 vectors. Now what we need? عايزين البيزس for this W. So what are the bases? البيزس أول حاجة already they span the space. Okay, they span the space. But are they linearly independent? 100% I'm quite sure linearly independent. Not linearly independent. They are dependent. Why? لأنه الكبير R3 I need 3 linearly independent. How come? This the smaller one I need 4. So definitely 100% they are linearly dependent. حتى لو هو ما كلمني I'm quite sure يبقى they are not the bases. ما كلهم هم البيزز. Which ones I should cancel them? How can I generate? Which ones are important to generate this one? Clear? طيب هعمل شنو؟ What we do? Just put them. See which one? طيب here how you will find which are the basic ones. Which ones are independent and the others are dependent on them. What we do? We let احنا عشان نعرف dependent or independent C1 X1 plus we let it equal to 0. Yes, before we try to find the C's. Yes, so we do the same, but we reduce to the echelon form. When you reduce to the echelon form, you will reach here. Then the columns that has leading ones, these correspond to شنو? To the elements that are going to be in S and linearly independent. هل هنا في leading one? No. Here leading one? No. So لأنه هنا الرو الأول this is the leading one. Here الرو الثاني this is the leading one. Here has no leading one. يبقى في this column this is the leading one. In this column this is the leading one. Here there is no. Correct? يبقى now what are the bases? The bases column ده what it was? It was this. So 1 2 2. And the second 2 3 1. How many are they? They are 2. يبقى الدايمنشن is كم? Is 2. The space is spanned by شنو? By these 2 vectors. The others were extra. Okay? Can the same space have other? Yeah, يعني لو خطيت this first or this is the second and this is the last. Can I have new other bases? Yes, you can generate other bases. But all they will be of dimension 2. Clear? So here enough to generate this space W by these 2 vectors. Okay, and the others are going to be dependent, or I can find them even themselves from these 2 vectors. And to generate the whole space, it's enough this and that. So they are the bases. Clear? يبقى this subspace. Okay, a dimension of it is what? Is 2. Although it is subset from R3. I need only 2 vectors to generate it. So a dimension حقه is 2. Clear? So we finish this chapter. Okay, and I'm going to start the new class. If you have no questions, do you have any questions? Do you have any questions related to this one? Any questions? Okay, then I'll stop this class. Stop here.